Okay, in this video, we're going to talk about section 6.1, which is inverse functions, and we have some kind of experience working with inverse functions, but we're going to review that experience today. First of all, we're going to talk about one-to-one relationship. One-to-one relationship is where every y value has only one x value. Now that sounds pretty familiar. That sounds a lot like a function. In a function, however, it says every x value has only one y value. So a one-to-one relationship flip-flops that x and y role. So every y has only one x value. Now a one-to-one relationship passes something called the horizontal line test. So if we had a relationship, if we had a bunch of points that we had plotted, and maybe that bunch of points forms a graph that looks like this. Well, this thing is certainly not a function. It fails the vertical line test. But every y value has only one x value. This y value up here has only one single x value. And this y value right here has a single x value that has caused that. So every y has only one x, and this will pass horizontal line test. So this is a one-to-one relationship. But a one-to-one relationship does not have to pass the vertical line test. You could have a one-to-one relationship that looks like this. Now that passes the horizontal line test. That's a one-to-one relationship. That's also a function because it passes the vertical line test. And something that we'll mention right now is that the inverse, we haven't talked about inverses yet, but the inverse of a one-to-one relationship inverse of a one-to-one relationship is a function. Now let's review this whole inverse thing. If a relationship has domain A and range B, so these are all the possible x values, these are the resulting y values, then the inverse of this relationship has domain B. These are the x values of the inverse. It's got a range of A, so this set of numbers is going to be the set of y values that result from those x's. So what happens with inverses is that the x's and y's switch places. So let's say a relationship has the point 4, -5. Name a point that's on the inverse. Well, according to what I've read up here, what I've got to do is I've got to switch the x and y. I've got to switch the domain and the range. So a point that's on the inverse would be -5, 4. So anytime I'm asked to graph the inverse of function or of any kind of a relationship, what I'm going to do is I'm just going to switch the x's and y's, and I'm going to plot those points. And then I will be plotting the inverse. Now, on a graph, what does that look like? Well, what it says here is a relation and its inverse are reflections over y equals x. So this point up here was on the relation. Point 4, -5. Now let's graph that. 1, 2, 3, 4, 1, 2, 3, 4, 5 right here. Now let's graph its inverse. So this one was on some relationship, some ordered pairs. If we graph the inverse, that would be negative 5, 1, 2, 3, 4, 5, and 4. And this is the line right here, y equals x. Now, does it look to you as if these guys are reflections of each other over that line? And yeah, they do look like reflections. It does look like if I folded my paper along this line, y equals x. If I folded right along this guy, looks like those points would land right on top of each other. So any relation or any point and its inverse, any figure and its inverse are reflections over the line y equals x. And just to show what that might look like, this was my original point down here. You know what I'm going to do? I'm going to make something out of this. I'm going to make a triangle. Let's say I make a triangle that goes like this. Now, let's see. This is the point 5, 0. So what point is on the inverse? Well, if I switch the x and the y, I guess it would be 0, 1, 2, 3, 4, 5. This point right here is on the figure. Now this is the point 0, negative 3. So what point is on the inverse? I got to switch the x and the y, and that would be negative 3, 0. Does it look as if these figures are reflections over the line y equals x? And yeah, if I folded my paper right along that line, it looks like these guys would land right on top of each other. So if I ever want to graph a figure and its inverse, just plot those important points and then reverse the x and the y and plot those points, and you've got the inverse. Now here's something that I think you've done before. You're given y equals 2x cubed minus 4, and you're asked to find the inverse of that function. And what you've done before, and this may not come to mind, but when I talk about it, I think you're going to remember it. What we're going to do to find the inverse of this is we're going to switch the roles of the x and the y, just like we did when we were plotting points. Instead of saying y equals 2x squared, 2x cubed minus 4, I'm going to say x equals 2y cubed minus 4. The x and the y switch roles. And now my job is to solve for y. And when I do that, I'll have the inverse of my original function up here. My original relation, whether it be a function or not. Okay, let's solve for y. I think the first thing I do is add 4 to each side. So add x plus 4. 2y cubed. Okay, in an effort to get y all by itself, what would you do next? I think I'd divide by 2 also. So x plus 4 over 2 equals y cubed. And now, in an effort to get y all by itself, I think I'd cube root each side. And so the cube root of x plus 4 over 2, remember to make this a cube root, that is equal to y. And that is the inverse of what we started with up here. And since it's the inverse, instead of calling it y, I think it would make the most sense to call it y inverse. That doesn't mean this thing right here doesn't mean 1 over y. This means y inverse. And so if I graphed this guy on my calculator, and I graphed this guy, y equals cube root of x plus 4 over 2. If I graphed those on my calculator, I think I'd find that those are reflections over the line y equals x, and you can try that if you'd like. All right. You know, I just better make sure there wasn't anything else. There was nothing. Okay. Now, there will be times when you'll be asked to find the inverse of something. Let's find the inverse of this function. Let's evaluate that at 3. Well, okay, if we think about trying to find the inverse, and don't write this down, but I'd consider this thing to be y. Here I've got an x right here and an x right here. I'm gonna switch the roles. I'm gonna try to find the inverse. And so, and again, don't write this down. I would say x is equal to 3 plus y squared plus tan pi y over 2. Switch those around, the x's and the y's. Now, let's solve for y. Well, you'd look at that and you'd say, you're out of your mind. There's no way I can get y all by itself. And you're correct. You can't get y by itself. And if you can't get y by itself, then how the heck are you going to evaluate this inverse, which you can't even find at 3? And yet you're going to be asked to do just that. Well, if you're asked such a question, here is how you're going to attack it. You're going to start with what you're asked to find. You're going to say f inverse of 3 is equal to I don't know. If I knew, I'd answer it and I'd be done. And if f inverse of 3 is equal to question mark, then we know that the inverse of that, which is the original function, switches the roles of the x and the y. So f of what is equal to 3? Our goal in this problem is to figure out what is the value of question mark. What is f inverse of 3? I don't know. But if I then go back to my original function and say f of what is equal to 3, well, what would you put in for x? What would you put in for x so that the value of this thing is equal to 3? Now, it's got to be something simple. It's got to be something obvious. Simple numbers are things like 0 or 1, or depending on what the function is, it's going to be something obvious. It's not going to be something you're going to grab your calculator for. What would you put in for x? So that f of this thing results in a value of 3. And I think you would look at this and I think you'd say, well, I think I put a 0 in there. 3 plus 0 squared plus the tangent of what amounts to be 0. And the tangent of 0 is 0. So 3 plus nothing, yeah. F of 0 gives you 3. So f inverse of 3 is equal to is equal to 0. Now that's going to take a little bit of practice. We're going to get a little bit of practice on the next slide. We're going to get a little bit of practice in our assignment. All right, let's try the next one. This is the final slide. Katz's theorem of inverses. If we know that f of A is equal to B, then f inverse of B is equal to A, because we just flip-flop the roles of the x and the y values. Now, we know that. Okay, that's something that we already know. We don't know how to spell so good, but we know that. Let's try it again. But now something that we don't know. This is what the theorem says. The theorem says if we take the derivative at A, if I find f primed at A, and I find that the value of that derivative, I'm going to call it W. I'm not going to call it anything. I'll call it W because I like it. Then the derivative of the inverse at B, the derivative of this guy right here, the derivative of the inverse at B is the reciprocal of that W. What? Well, let's see what that looks like. Now, our job is to find the derivative of the inverse at 1. And I'm going to tell you that this method I refer to as the horseshoe method. Let's see how my spelling is here. It looks a little better. It's called the horseshoe method because it starts in one place and it ends at your final answer right down here. Okay, let's take a look at this. Now, here's how we start. Remember that I am looking for f inverse primed at 1. And the way I start this is I say this. I'm not going to start with the answer. I'm going to end up with the answer right down here, remember. I'm going to start with f inverse of 1 is equal to I don't know. Because I don't know what f inverse of 1 is. Then f of I don't know is equal to 1. Okay, now I got to figure out what question mark is. I got to figure out what question mark is. What am I going to put in for x? What will I put in for x? So that my result is a value of 1. So I think about that a little bit. I remember that Mr. Potts told me that this has got to be something that's kind of obvious. And so I try easy numbers. I try easy numbers like 0 or 1, something like that, maybe pi. But if you think about this, if I put a 0 in here for x, I get 0 plus the cosine of 0, and the cosine of 0 is 1. So I know that question mark has a value of 1. And that's what I'm doing on the top part of my horseshoe here. Now it's time to turn this thing around, and instead of talking about a function and its inverse, now we're going to talk down here about the derivatives. So although I've got to answer a question about the derivative, I didn't start by attacking the derivative. I dealt with the inverse and the function, figured out what question mark is, and now we're coming back around. And when we come back around, what we're going to say down here is, okay, I know question mark is 1. So what I want to know is what is f primed, oh, I'm sorry, no question mark is 0, I'm sorry. I don't mean to confuse you on that. I said 0 and I wrote 1. I would like to find f prime of 0. Now that's going to take a little bit of work. I mean, what is f primed of x? Oh, these aren't going to be really tough derivatives. Derivative of this is 2. Derivative of this is negative sine of x. So what is f primed of 0? Well, that's going to be 2 minus the sine of 0. And if we know our unit circle, which I'm sure we do, we know f primed of 0 is equal to 2 minus nothing is 2. So let's finish off our horseshoe. Let's answer the question at hand. And the question at hand is, what is f inverse primed of 1? Now let's come back up here to Katz's theorem. And Katz's theorem says find the derivative of the function, because the derivative of the inverse will be the reciprocal of that. We spent our time finding the derivative of the function. We found that was 2. And there was no way to find the actual inverse function. So we used the function. We found its derivative at 0. So the derivative of the inverse at 1 is going to be the reciprocal of this guy. It's going to be 1/2. And that is the final answer to this problem. Now that kind of is a head scratcher and a head spinner. So let's practice it again. Let's talk our way through this thing. Let's talk our way through this horseshoe method. Here's f of x. I got information about f, and I think it would be difficult to get, not impossible, but it would be difficult to find the inverse of that. So let's use this horseshoe method. My goal is to find f inverse primed at -4, so I'm not going to start with the derivative. Remember, the derivative happens down here on the bottom part of the horseshoe. The top part of the horseshoe is the inverse. F inverse of -4 is equal to, I don't know, and f of, I don't know, is equal to -4. What are you putting in for x? What are you putting in for x so that this thing results in a -4? And I think you can look at this and say, well, I got my -4 right here. If I put a -1 in here, I'm going to have 0 cubed is 0 minus 4 is -4. I think question mark has got to equal -1. Awesome. Now let's bring it on back. Now we're talking derivatives. Now that we're on the bottom of the horseshoe. I would like f primed at -1. And what's that equal to? Well, let's find f primed of x. Let's see, I would, the chain rule, I think I would have a 3. X plus 1 And this with the inner function squared times the derivative of what's inside, which is just 1. And then the derivative of negative 4 is 0. So what is f prime at negative 1? Well, if I put a negative 1 in here, I think I'm going to get 0 times 3, and I'm going to have to square that 0 and multiply. I'm getting a 0. So what that leads me to is, what is f inverse prime at negative 4? Well, it's the reciprocal of that. It's 1 over 0. Well, what is that? And you're probably tempted to say, well, it doesn't exist, and that's true. Would you realize that this is a horizontal line here when the derivative is 0? So this is going to be, what kind of line is that when it's got a slope, when it's got a derivative of 1 over 0? I think the more appropriate thing to write here, whoops, again, I'm looking for an eraser. I think what we're going to write here is that this 1 over 0, we're going to say that slope is infinity. We're going to get ourselves a vertical line. So the assignment is posted in Schoology, and we'll talk about this when we get back next week.